Hi, this is SOSF. Alright, so check this out. Someone sent me this insane scientific paper. It's one of those things that sounds like a dumb movie plot, but when you actually get into the weeds with the science, it completely unravels your brain. The whole premise is this: what if we could shrink a human being? Not like, they lose a little weight. I mean, like, full-on Honey, I Shrunk the Kids style. You take a regular person, say, 5'7", 150 pounds, and you hit him with a shrink ray. Zap! Now they're 100 times smaller. So you go from about 1.7 meters tall to 1.7 centimeters tall. You're the size of a bumblebee. Your new weight? 70 milligrams. That's lighter than a postage stamp. We all think of this as a fun adventure, right? You ride on the back of an ant, you fight a scorpion in the backyard. It's a whole fantasy movie. But these scientists, they went through it step by step, with the cold, hard laws of physics. And man, it is a horror show. An absolute, non-stop biological nightmare that you would not survive for more than a few minutes. It's not an adventure, it's a death sentence. And the executioner is just math. The whole thing comes down to this one fundamental principle that most people have never heard of, but it governs literally everything about how living creatures work. It's called the square cube law. It sounds complicated, but the idea is actually pretty simple. Some dude, Galileo, figured this out way back in the 1600s. He basically said that when you scale an object up or down, its surface area and its volume don't change at the same rate. Let's say you have a little sugar cube. It has 6 sides, right? That's its surface area. The inside, the actual sugar, is its volume. Now, if you make that cube twice as tall, its surface area goes up by a factor of 4. That's 2 squared. But its volume, the amount of stuff inside it, goes up by a factor of 8. That's 2 cubed. See how the volume grows way faster than the surface area? Now, let's run it in reverse. You're shrinking. We shrink you down 100 times. Your surface area, your skin, it gets 10,000 times smaller. That's 100 squared. But your volume, and your mass, all the guts and bones and muscle inside you, that gets 1,000,000 times smaller. That's 100 cubed. This is the whole ballgame. This one little piece of math is why being shrunk would suck so bad. Your volume, which is where your body produces heat and contains all its machinery, has shrunk into almost nothing. But your surface area, which is where your body loses heat to the outside world, is now ridiculously, disproportionately huge compared to your volume. The ratio of your skin to your guts is 100 times bigger than it is right now. So, what's the first thing that happens the second you're shrunk down to the size of a Lego figure? You freeze. Not slowly. Instantly. Think about it. Your body is a little furnace. Your metabolism is constantly burning fuel to keep you at that nice 98.6 degrees Fahrenheit. That heat is generated by all the cells inside you, your volume. But you're constantly losing that heat to the air around you through your skin, your surface area. For us, at our size, it's a balanced system. But for the tiny you, you're losing heat 100 times faster than you're designed to. It would be like taking a red-hot marble out of a forge. It's tiny, it doesn't have much heat stored inside, and it has a relatively big surface. It cools down in seconds. You'd be the marble. The heat would just pour out of your body into the environment. The scientists in this paper say you'd suffer from catastrophic hypothermia almost immediately. You wouldn't even have time to realize you were in a giant's backyard. You'd just be a frozen little human statue. It's the same reason why babies and small children get cold so much faster than adults. They've got a higher surface area to volume ratio than we do. But what we're talking about here is that effect on methamphetamines. It's dialed up to an absolutely unsurvivable level. Okay, but let's say for a second that you could somehow fight the cold. Let's say you've got a will of steel. Your body's only option would be to crank its furnace up to 11. Your metabolism would have to go into a gear that doesn't even exist in human biology. They brought up this animal, the Etruscan shrew. It's one of the smallest mammals on Earth, weighs less than a dime. This thing's life is pure, high-octane anxiety. Its heart can beat up to 1,500 times a minute. That's not a typo. 1,500. And to fuel that insane metabolism, it has to eat 1.5 to 2 times its own body weight every single day. If it stops eating for a few hours, it dies. It just burns out. Now, according to the math in this paper, your metabolic needs as a tiny human would make that shrew look like a lazy, hibernating bear. Your metabolism per pound, or, I guess, per milligram, would have to be more than 120 times what it is now. You'd need to be consuming, constantly, more than 150% of your body weight in high-energy food every day. So, picture this. You're 1.7 centimeters tall. You need to find and eat a pile of food bigger than you are every single day, without stopping. But here's the kicker. Even if you were sitting in a mountain of pure sugar, you'd still die. Your human digestive system, your little tiny stomach, your microscopic intestines, wasn't designed for that. It's like trying to fuel a blast furnace with an eyedropper. You physically could not process the calories fast enough to keep from freezing to death. It's a fatal energy bottleneck. Your body is screaming for fuel, and your machinery is just not equipped to handle the demand. You'd starve while being surrounded by food. It's a special kind of hell. So you freeze to death, and if you don't freeze, you starve to death. But let's say we solve that too. Magic. You have a perfect internal heater and an infinite energy source. What's next? Oh, right, you suffocate. Your breathing is also totally screwed by the square cube law. You need oxygen, right? Your lungs work by having this enormous surface area. If you flattened out all the little sacs in your lungs, the alveoli, they'd cover a tennis court. That's a huge area for oxygen to get into your blood. When you shrink 100 times, that tennis court becomes the size of a ping-pong table. Your lung surface area shrinks by 10,000 times, but your demand for oxygen, because of your insane new metabolism, has skyrocketed. So you have way less machinery to do a job that is now 100 times bigger. But it gets weirder and much worse. The physics inside your tiny lungs turns against you. The insides of your lungs are wet. In those tiny, shrunken-down lung sacs, the surface tension of that thin layer of water becomes a dominant force. Think of how water droplets stick together. Now imagine that happening inside you. Every time you'd breathe out, your lung sacs would collapse and the water inside would glue them shut. They'd be stuck together like wet pages in a book. You wouldn't have the muscle power to pull them open again. It's a real medical condition in premature babies who haven't developed the natural chemical that breaks that surface tension. For a tiny you, it would be a guaranteed, immediate death by asphyxiation. Your own lungs would trap you. And even if you could keep them open, more magic, you still couldn't get enough oxygen. Your heart would have to be beating at some hummingbird-like speed to pump blood around. That means the blood would be rushing through your lungs so fast, there wouldn't be enough time for the oxygen molecules to actually jump from the lung sac into the red blood cells. It's like an assembly line that's moving too fast for the workers to put the parts on the car. The oxygen is right there, but your blood is just zipping past, empty. And speaking of red blood cells, here's another thing that will absolutely bake your noodle. When you shrink, your cells don't shrink with you. A human cell is a certain size, and that's that. So a 1.7 centimeter tall person isn't made of tiny microscopic cells. You're made of the regular number of cells, just way fewer of them. 1,000,000 times fewer. What does that mean? It means your organs aren't just smaller versions of your organs. They are fundamentally different, and broken, structures. Think about your blood. Your red blood cells are a specific size, about 7 or 8 micrometers across. They have to squeeze through your tiniest capillaries as it is. Now you shrink the capillaries by 100 times. They're now less than 1 micrometer wide. A red blood cell, which hasn't shrunk, can't fit. It's like trying to shove a pickup truck through a doorway. The result? Every single one of your tiny blood vessels would be instantly clogged. Massive, system-wide blood clots. Your circulation would stop. Dead. But the craziest part, the part that really ends the whole discussion, is the brain. The human brain has something like 86 billion neurons. That's what makes you, you. That's your consciousness, your memories, your personality. All those neurons are regular-sized cells. You can't shrink them. So how do you fit 86 billion neurons and all their supporting structures into a skull the size of a pea? You can't. It's physically impossible. You wouldn't have a shrunken human brain. To get down to that size, you would have a brain with 1,000,000 times fewer cells. You'd have the brain complexity of an insect. So the entire premise of the movie, that it's you, your personality, just in a tiny body, is a biological impossibility. You wouldn't be you anymore. You'd be a tiny, shivering, suffocating creature with the intelligence of a grasshopper. It's just a cascade of total systemic failure. Every single thing that keeps you alive breaks. And it all goes back to that simple square cube law. Okay. So the paper basically says you're dead, instantly, and in about 5 different ways at once. But this is where it gets fun. Let's pretend you're not. Let's use sci-fi movie magic and say you've been re-engineered to survive. You don't freeze. You can breathe. You're still you. Now what? Now you have to exist in the world. And the world you knew is gone. The physics of your everyday life has been completely rewritten. At our scale, we're ruled by gravity and inertia. We fall down. It takes effort to start and stop running. At the 1.7 centimeter scale, those forces barely matter anymore. You are now the king of a new kingdom. The kingdom of surface forces. Things like air resistance, surface tension, static electricity, things we barely even notice, are now the gods of your universe. First, the air. The air we walk through feels like nothing. But for you, it would be like swimming through honey. The viscosity of the air, its stickiness, would be a huge drag on your tiny body. Every step would be a struggle. Trying to run would feel like trying to run through a pool of molasses. Then there's water. Water is no longer your friend. A puddle is a lake. A single raindrop is a planetary scale disaster. If a drop of morning dew falls on you, you don't get wet. You get trapped. The surface tension of water, that invisible skin that lets insects walk on it, would be like a shrink-wrapped cocoon of death. It would grab you, surround you, and hold you. You wouldn't have the strength to break the surface tension to get out. You'd just be stuck inside a shimmering, inescapable ball of water until you drowned. Insects have waxy, water-repellent bodies for this very reason. Our soft, smooth skin would be a fatal liability. Your senses are also completely shot. Your eyes? Useless. They're now so small, with such a tiny pupil, that the laws of optics betray you. Light actually bends and smears out when it goes through a tiny opening. It's called diffraction. The result is that you wouldn't be able to form a clear image of anything. The world would be a meaningless, blurry mess of light and color. You'd be legally and profoundly blind. Your hearing would be just as weird. Your tiny eardrums wouldn't be able to vibrate from the long, slow sound waves of a human voice. Normal sounds would be too low frequency for you to even register. The world would seem eerily silent, but you would be able to hear ultra-high frequency sounds we can't. You'd hear the squeaks of mice as loud conversations. The buzzing of insects would be a deafening roar. It would be a completely alien soundscape. And you'd be living in a world of new monsters. You have fallen off the top of the food chain and landed, with a tiny splat, right at the bottom. A common garden spider is now a hairy, eight-eyed beast the size of a tiger, waiting in ambush. A praying mantis is a dinosaur. A dragonfly is a high-speed attack helicopter. And ants. Man, think about ants. We see them as a nuisance. At that scale, an ant is a heavily armored biological tank with terrifying crushing mandibles. And they don't come alone. An ant colony wouldn't be a little mound in the grass. It would be a hostile, alien city populated by a million-strong army of relentless soldiers. If they found you, you'd be a curiosity, and then you'd be food. You would spend every second of your existence in mortal terror, hiding from creatures you used to step on without a thought. So, the paper establishes this pretty clearly. A simple, magically shrunken human is a dead human. It's impossible. So then they ask the next question, the real sci-fi question. Okay. If we can't just shrink a person, could we rebuild them to survive at that scale? And this is where it goes full-on transhumanist cyberpunk. The answer is maybe, but the thing that would come out the other side wouldn't be human anymore. It would have to be a completely re-engineered life form. First, you'd need a suit, a full-body, sealed microenvironment suit. It would need to be insulated with something insane, like aerogel, just to keep you from freezing. It would need its own life support system, a tiny scuba tank and CO2 scrubber. It would have to be armored to protect you from, a bee sting that would be like getting impaled by a telephone pole. How do you power this thing? Batteries are terrible at that scale. They don't hold enough juice. So these scientists are talking about wild solutions, like using piezoelectric materials that generate electricity from your own movements. Or, get this, a tiny biofuel cell implanted inside you that runs on your blood sugar, turning you into a biological battery to power your own survival suit. Your failed senses would have to be replaced. Tiny cameras for eyes, miniature microphones for ears, all wired directly into your brain through a neural interface because your biological parts are useless. You'd be a cyborg. And that's just the tech. The biology itself would need a complete overhaul. They're talking about massive genetic engineering. Using CRISPR to rewrite your metabolic pathways, make you burn energy more efficiently. Maybe give you the ability to go into torpor, like a hibernation state, just to conserve energy overnight. They suggest redesigning your entire respiratory system. Maybe getting rid of the lungs altogether and replacing them with a system like an insect has, with little tubes that deliver oxygen directly to your tissues. They'd have to solve the cell problem, maybe by engineering synthetic, smaller cells to build functioning microorgans. You'd be a custom-built creature from the ground up. And this brings us to the end of it all. The big, weird, philosophical question that makes this whole thought experiment so damn interesting. If you do all that, if you change a person's metabolism, replace their respiratory system, give them artificial senses, wrap them in a powered suit, and rebuild their organs from scratch, is that creature still human? It's the ship of Theseus paradox, right? If you have an old wooden ship, and over the years you replace every single plank of wood, is it still the same ship at the end? So if you take a person and you replace every biological system they have just to let them survive at a tiny scale, what's left? Is that you? Is your consciousness, your identity, just something that can be poured into any container, no matter how alien? The price of survival in the micro world might be your own humanity. You'd have to destroy the human to save the person. And what a strange, lonely existence that would be. A ghost in a tiny machine, swimming through thick air, hiding from spiders, in a world you can no longer truly see or hear. It's a wild thing to think about, man. It makes you realize that our existence, the way we are, isn't just an accident. It's a solution that works, perfectly balanced by the laws of physics, at the very specific scale we happen to be. And if you mess with that scale, you mess with everything. See you next time.